Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. My name is Asrie Muhammad Kusairi. I am from Faculty of Applied Science. My ID number is 2023661444. And now, I will share with you guys about acid, base, and salt. First thing first, acid and alkali. Now, I will share with you guys about the basicity of acid. Basicity of acid refers to the number of hydrogen ion H+ that can be produced by an acid molecule that ionizes in water. So, acid divided by three parts, which is monophosic acid, diphosic acid, and triphosic acid. So, what do you guys need to know about this? Mono means one. So, monophosic acid only has one H+ per acid molecule. For example, we have hydrochloric acid. So, next for diphosic acid, we have two H+ per acid molecule. For example, we have sulfuric acid. So, lastly, we have triphosic acid, which has three H+ per acid molecule. For example, phosphoric acid. Now, I will show you guys the definition of acid. Acid is a chemical compound that produces hydrogen ion H+ or hydrotonium ion HCO+ when dissolved in water. Now, we are going to move on from acid to alkali. So, alkali, which is also known as the base, is a chemical compound that can neutralize an acid to produce salt and water. So, the example of formation of salt and water is hydrochloric acid with sodium hydroxide will combine and produce sodium chloride and water. Most bases are not soluble in water. So, what is the definition of alkali? An alkali is a chemical compound that dissolves in water that produces freely moving hydroxide ion. It is different from acid. Acid produces hydrogen ion while alkali produces hydroxide ion. Now, take note that bases that are insoluble in water are tin oxide, zinc hydroxide, copper 2 oxide, and copper 2 hydroxide. So, what is the example of alkali? The example of alkali is potassium hydroxide and sodium hydroxide. Next, I am going to share with you guys about the uses of acid, base, or alkali in our daily life. For acid, we have sulfuric acid, which can be used to make paint, polymer, fertilizer, and detergent. Next, we have benzoic acid that can be used to preserve food. For base, we have ammonia that can be used to make fertilizer, nitric acid, and fermented latex in liquid form. Other than that, we have calcium hydroxide, which can be used to make cement. After that, we have color of indicators in acidic and alkaline solutions. We have 4 indicators that we can use to find if that solution is acidic or alkaline. We have metal orange, universal indicator, blue litmus paper, and red litmus paper. I'm sure you guys have known about blue litmus paper and red litmus paper, so I do not need to share with you guys about that. What I want to point now is metal orange. When it is used in an acidic solution, it will turn to red, while when in alkaline solution, it will turn to yellow. Next, universal indicator. For strong acid, it will turn to red, while in weak acid, it will turn to yellow. Within alkaline, if it's a strong acid, it is copper. And if weak alkali, it is blue. Now we are going to move on to pH value. To determine the pH value, we have to know what is pH scale. pH scale is a set of numbers that can be determined the degree of acidity of alkalinity of a substance. So, the base value would be 7 for neutral substance. If it's greater than 7, it is alkaline substance. While if it's lower than number 7, it is acidic substance. So, you guys should note that if it's 7 in the scale of pH, it is a neutral substance. As you guys can see, this is an example of the pH scale with some substance. So, how to know if the substance is weak acid or strong acid or weak alkali or strong alkali? So, as you guys can see, the nearer the number to 0, it is known to be a strong acid, while if it's closer to 6, it will be known as weak acid. The formula is the same for alkali. When it is 8, when it is near to 8, it is called weak alkali. When it is nearer to 14, it is called a strong alkali. Next, we are going to learn about strength of acid and alkali. First, what is strong acid? Strong acid is a chemical substance that can dissociate completely in water to form free-moving hydrogen ions. For example, strong acid is hydrochloric acid. Next, weak acid. A weak acid is a chemical substance that can only dissociate partially in water to form hydrogen ions. For example, ethanoic acid and carbonic acid. So, for easier understanding, strong and weak means when it is strong, it means it dissociates completely, while when it is weak, it is dissociated partially in water. Get that? Next, it is the same deal as last time for alkali. For strong alkali, it means that a chemical substance that dissociates completely in water to produce hydroxide ions. For example, we have sodium hydroxide and potassium hydroxide. Whereas for weak alkali dissociates partially in water to produce hydroxide ions. For example, we have calcium hydroxide and aqueous ammonium. Next, we need to know about the chemical properties of acid and alkali. There are 4 chemical properties of acid, which is acid is corrosive, acid turns blue litmus paper into red, the pH value is less than 7, and acid tastes sour. Get that? Next, what is the chemical properties of alkali? Alkali turns red litmus paper into blue. Alkali also reacts with acid to produce salt and water. Alkali has a pH value more than 7. Alkali is bitter in taste and feels kinda salty. When alkali is treated with ammonia salt, it produces ammonia gas. After that, we are going to learn about salt, crystal, and their uses in daily life. Now, I will share with you guys about the physical properties of salt, which is a crystal. A crystal has a flat surface, straight sides, and sharp vertices. It also has a pitch angle between two adjacent surfaces. For your information, different crystals have different geometrical shapes. Next, we are going to talk about the definition of salt. The definition of salt is an ionic compound formed when hydrogen ion H+ from the acid is replaced with the metal ion or the ammonium ion. Example of salts and their uses. Firstly, in agriculture sector, ammonium nitrate can be used to make fertilizer. After that, iron sulfate also can be used to make pesticides. Next, for medicine sector, we have potassium manganate 7 that can be used as antiseptic to treat wounds. Other than that, we also have calcium sulfate that can be used as plaster of Paris to protect or support the broken bone. Next, for food sector, we have sodium chloride that can be used for food flavoring. Other than that, we have sodium bicarbonate that can be used to raise dough. Lastly, for preservation sector, we have sodium benzoate that can be used to preserve chili sauce. Lastly, sodium nitrate is used to preserve processed meat. Lastly, preparation of salt. You need to know what is soluble salt and what is insoluble salt. Soluble salt are salt that are dissolved in water at room temperature, whereas the insoluble salt is otherwise. So, what are you guys need to know and memorize about is for nitrate salt, all nitrate salt are soluble in water. After that, sulfate salt, all sulfate salt are soluble in water except lead sulfate, barium sulfate, and calcium sulfate. For the third one, chloride salt. All chloride salt are soluble in water except mercury chloride, lead chloride, and silver chloride. For carbonate salt, all insoluble in water except for 3, which is sodium carbonate, potassium carbonate, and ammonium carbonate. Lastly, the type of salt for ammonium, sodium, and potassium salt. All ammonium, sodium, and potassium salt are soluble in water. Get that? Last but not least, preparation of salt. Salt can be obtained by many types of experiments. For example, for insoluble salt, experiment that can be carried out is you can get insoluble salt by filtration, recrystallization, and double decomposition reaction. Other than that is to get soluble potassium and sodium salt, you guys can use neutralization through titration method, or you guys can also use evaporation method. Lastly, for soluble non-potassium and non-sodium salt, you guys can use the reaction of acid with metal oxide, metal hydroxide, metal, and carbonate. You guys can also use evaporation and recrystallization to obtain soluble non-potassium and non-sodium salt. I think that's all from me. Thank you.